This lesson is looking at the difference between mixed, entire, and simplest radicals, and how to convert radicals into simplest form and into entire radical form. So a mixed radical just means that you have a rational number outside the radical sign combined as a product with a radical. So things like 2 root 3. An entire radical is written entirely inside the radical sign. So something like square root of 45. When we are asked to express a radical in simplified form, it means, or simplest form, it means that there's no more factors that are perfect roots that we can take out. It also means taking any radicals out of the denominator of the fraction, but this lesson won't be looking at the denominator portion. Sometimes people think that all mixed radicals are in simplest form, but that's not the case. So I've given an example here where we're going to take our radicals and classify them as far as mixed or entire, and as far as simplest or not simplest. So this first one, if we look at it, 2 times the cube root of 7. Well, that's a mixed radical because we've got part that's outside the radical and part that's inside the radical. So it's definitely going to go in the first column. To decide if it's in simplest form or not, we have to look at, are there any perfect roots that can be factored out? So we're looking for cube roots that can be factored out of 7. Well, 7 is prime, no cube root can be factored out of that. So it is in simplest form. Square root of 15. Nothing outside the radical, so it's an entire radical. And if we look at the factors of 15, 3 and 5 are its prime factors. We can't take any perfect squares out of that, so it is also in simplest form. Square root of 250. Well, again, it's entire. There's nothing outside the radical. But 250 can be factored into 25 and 10. And 25 is a perfect square, so it's not in simplest form. 5 root 2. We've got something outside the radical, the 5, so it is a mixed radical. The root 2 part of it, we can't factor out any perfect squares, so it's going to be in simplest form. 2 root 8, another mixed one. This time, though, 8 has factors of 4 and 2. 4 is a perfect square, so it is not in simplest form. And I see this one here, I said it was in simplest form, but I pulled it into the wrong spot. So we can't factor anything out of the 2, so it should be in simplest form. 5 root 24, another mixed one. Cube root of 24, so we're looking for perfect cubes that can come out of 24 as a factor, and 8 is a perfect cube that can come out of 24, so it is not in simplest form. Root 5, another entire radical, nothing on the outside. Can't take anything out of it that's a perfect square, so it is simplest and entire. Last one, square root of 45, we can take out 9 as a factor, and that is a perfect square, so it's entire and not simplest form. So they can fit into more than one category. So if we want to switch from simplest form to entire radicals, or vice versa, we can look at our steps for that. So first of all, to put a radical in simplest form. So first step is to factor out any perfect nth powers. Some people like to do this with a factor tree. If you do know your perfect squares and cubes, that can be a little bit quicker. I will show both ways. Then we want to write the radical as a product of the perfect factors and of any remaining factors. Lastly, we eliminate the radical for those perfect factors, right? We take them out of the radical. So if we look at square root of 45, that was one of the ones we had over here earlier, and I said 9 is a perfect square. So if you don't know your perfect squares, it's handy to make yourself a chart like this one to the right, where you've got your list of numbers, all the perfect squares, all the perfect cubes, all the perfect fourths. So 45, we have the perfect square that's 9 that can factor out of that. Well, 9 times what is 45? 9 times 5. So we can write it like that. And then we know the square root of 9 is 3. So this becomes 3 root 5. Right? So we factored that out, wrote it as a product of the factors. Then for the perfect square, we took it out of the radical and just made it 3. This works with cube roots as well. So what cube can go into 81? 27 times 3 is 81, so we can split that up. Don't forget the cube root. Right? When we have an index in there, we got to keep it on each part. So cube root of 27 is 3, but the cube root of 3 we can't do anything else with, so we leave that. Now this next one, a lot of people, when we have bigger numbers, the next two actually, like to do factor trees. So if you want to do factor trees on these ones, that is perfectly okay. So to do a factor tree here, right, just going to do it off to the side, 162. I can split it up into whatever goes into 162, so 2 times 81. Now at this point you might say, oh, 81's a perfect square, right? Right there it is in our perfect square list. But if you don't recognize it as a perfect square and you keep going, that's okay. So that's 3 times 27, 3 times 9, and 3 times 3. So what we're looking for is factors that show up in pairs for a perfect square. So 3 times 3 and 3 times 3, those are perfect squares. So if we split it up using our prime factors from our factor tree, we get 3 squared, another 3 squared, and don't forget the 2 that are left over. The 2 that is left over. So each of those still inside our radical sign. Now some people really like this method because we can easily show square and square root canceling out, square and square root canceling out. So this leaves us with 3 times 3 root 2, or 9 root 2. Note we would have got the same result if we had just said 2 times 81, right, and done the square root of 81, we would have got 9. So it doesn't matter which method you use, as long as you are somehow factoring out those perfect squares and canceling the radicals, right, taking them outside the radical. So 648, another one you might want to make a factor tree for. So 648. We get 162 when we take out 4, and we can factor that down. Now this time it's a cube root, so instead of looking for pairs of factors, we're looking for triplets of factors. So I've got 3 2s, 3 3s, and a 3 left over. So when I split it up, I'm going to do it below here, I'm going to have 2 cubed, 3 cubed, and 3. Remember to put each of those inside the original radical, so in this case that's cube roots. So cube root and cube cancels, cube root and cube cancels, we get 2 times 3 times root 3, and 2 times 3 is 6 on the outside, root 3. One thing to watch out for is that sometimes you take out a factor and you haven't taken out all the factors. It's not considered to be in simplest form until all factors that are perfect roots have been taken out. So just going back to our original example where we're replacing them, right? You can end up with a mixed number, but if it can still be reduced, right, we could take out 8 as a perfect cube here, 4 as a perfect square here. It's not considered in simplest form, so be careful with those ones. Going the other direction, if we want to convert mixed radicals to entire radicals, we are putting things inside the radical. So while we put it inside the radical, we also apply the corresponding power. So if we put a square root and a square on a number, we're not changing the value of that number. If we put a cube root and a cube on a number at the same time, we're not changing the value because those two things cancel each other. So we do that in order to put it inside the radical, and then we can multiply the two radicals together. So first example here, 5 times the square root of 3, we want it inside the square root. So if we put the 5 inside the square root, we also have to square it. So we can work that out. That becomes 25 times 3, and we can write it as 1 radical root 75. Works with cube roots as well, but remember to cube your number when you put it inside the cube root. So this becomes cube root of 8 times the cube root of 7, which gives us the cube root of 56. And our last example, 4th root, so be careful with these ones. So we get 4th root of 4 to the power 4, right, because we apply the 4th root and the 4 at the same time. So 4 times 4 times 4 times 4 gives us 256. Times the last remaining 4 gives us 1,024. So we can go either direction, right? Either from a mixed radical to an entire radical like these ones, or we can simplify the radical and end up with a mixed radical. Make sure when simplifying it is completely simplified, that no more perfect roots can be factored out.